Today I want to explain a little about the Potts milling spindle, as I now have two of them and there's a bit of information I can share with people. They're basically a simple, invaluable tool that enables a lathe to be used for clockmaking work, which requires a lot of indexing and light milling work. I bought mine originally, the first one, as a very expensive semi-antique, and it has worked brilliantly. I've been very pleased with it, and when another one came up on eBay just recently, I could see what it was, despite the fact the person who was selling it didn't seem to know, and it wasn't listed as a Potts milling spindle. I could see that at least the castings looked to be original Potts ones, but the photographs were not all that clear, and it wasn't too obvious until I got it exactly what the status was. But anyway, enough of that. This is how I put the milling spindle on the Boxford. Take off the top slide and tool post, and then I've got the same fitting exactly on the underneath of here, which I made up myself to fit on the bottom of here. And that is just tightened up with a screw in the usual way, and there's an indexing circle around the edge of the base of the tool post here, and there's an indexing mark on the bottom of here, so it's quite easy to set up. If you want to, you can set them up using a engineering square off the chuck, or you can use a 1-2-3 block. But I find that works fine for me. There's also an indexing mark on the top of here, so when you mount the spindle itself, onto there, and I can fit it on like that, which takes me to just below, well, it takes me down below centre height. If I just slacken off that and drop this down, I can go down below centre height, or I can come up. I'll just tighten this all up a little bit just to give you an idea of the range of movement it's got. So the way I've organised this, I made this fitting on here, is to get it to move from the position of drilling into something to that position. I slacken off this screw here, which is a clamp bolt, and get it into that position. And that gets me into being able to be at right angles. So it doesn't need any more alteration or taking apart or anything. I thought when I originally made it I'd probably end up having to take it apart each time if I was altering things, but no, it works fine like that. So if you've got a cutter in here, you can get that down just below the centre height of the lathe, and you can cut quite a big wheel. 3.5 inches or so above centre height, and give you an idea of what size of wheel it will cut. This was just at the limits of what I could manage, and I cut the teeth, or the slots actually, for this using the milling spindle. And that wheel is where I made the slot cuts, is 155 millimeters. When I bought the milling spindle, just wind this down a bit, when I bought it, it came with this spindle cartridge inside it, which sticks out quite a long way behind and projects further forward, and this is a solid hardened bearing inside here, with bronze bushes in the end of it and a fibre bushing at this end. I prefer to have roller bearings or ball races, so I changed and made a special spindle to go up inside here to replace this one. So inside here there are deep groove ball races. I put 2 at the front and 1 at the back. Ideally I would have had angular contact bearings, but I couldn't find them small enough with a shield on to go in here, so that's what I'm going with at the moment, and this has worked fine without any problem. So it's got 2 at the front to take most of the axial load. It also had a drive motor that was driven by a jockey wheel, which I kept the original parts because it's nice to have them with it. They're obviously made by the manufacturer, beautifully made, but clearly I wasn't going to be using some system of long belts and drives and things in the old-fashioned way of things. But it did come, the original one, with 10mm collets, which I thought the collets were quite handy. So when I made this spindle up, this is an ER16, just as you get off the internet, 150mm, 10mm wide, which is a very small size, but it is just the right size to go through the bearings that I chose. And that then enables you to have a 10mm collet, which is a very handy size to have. So if you've got any spare 10mm collet blanks or that sort of thing, you can make those up into cutters nice and easily, which is what I've done here. So those I use quite a bit, and I've also got 2 of these chucks. So they're with 10mm or almost 10mm size, and I even made one to take cutters to take the very large cutters that I've got for cutting large gear wheel teeth, so I can cut quite a lot with this, rather amazingly. So it's quite a handy choice that I made. Now the motor was an issue. I wanted to get the smallest, handiest little motor I could, and in the end I went for a Nanotec made in Germany motor. It's 24 volts, so there's no chance of getting electrocuted on the lathe. It was originally for used on a CNC machine, so it's got pacer here, which I've just disconnected, and all I've got is the 3 wires to drive the 3 phases of the motor. It did get a little bit hot when I was running it for extended periods on trial, and I consulted the manufacturers, and I decided to fit a fin jacket around the outside of it with some heatsink on, and that made it absolutely perfect. So it's a small, very powerful 220 watt motor, and drives on a standard TrueFlex belt, and that's worked fine, and I haven't needed to change the pulleys. To drive the motor, I have inside this box a 240 volt 24 volt transformer. It has an on-off switch and then a speed controller here, and that's the connector that I use to go up to the motor here, and it goes in forward or reverse just by reversing the wires. And that has worked well since I've built it, and I've housed it in a little case. It is slightly more expensive doing it this way than using a brushed motor, but it's a more elegant solution. So just to recap, inside here are ball races in a cartridge that I've made up that slips inside, and where that slit is there's a bolt that pinches that up, and apart from that, the only thing that I found is it can sometimes, if you don't tighten things up, twist, and there's a little bit of play in here unless you tighten this clamp up, and that tightens up onto the column. That's absolutely rock solid then. It's a very nicely made small little piece of kit, and very well thought out, and there's nothing made since to replace it, and I'm really quite surprised that some manufacturer didn't continue making them, although I suppose that they originally, the demand must have fallen off. Now I'll just bring out the new one that I've just got, and you can see the differences. Let's wind that to one side. I've just put this loosely on here. This is the one I've just acquired, and it looks on the face of it quite different, but when you study it you can see that the castings are definitely from pots. There's no doubt that that's where they came from, and it looks as if it was amateur machined, having bought the castings, which are not unusual to have happened. The thread on here is a fine thread standard screw. I can do better than that, so I'll change that. I'll turn the handle the same as this, nice and round, and it needs a handle on the top, which this hasn't got. And the other thing, the curious thing, is that this has been mounted upside down. If you look at it, that should be on that side, turned up the other way. So I'll reverse that, put it back the right way. I just don't quite understand why it's been put on incorrectly. And similarly, that is on the underneath when it should be on the top, so no problem to correct it. But the good thing is that there's quite a decent finish on here, and as there was originally on here, as there is on here, absolutely mirror finish on there. This is good, this is fine, and there doesn't seem to be any slop in it, so that will be fine. And the mounting of this on my rivet lathe, which is what I shall use it on, I've already made a plate, an adapter plate, to go on the bottom, and it has a new rod going through which clamps onto the adapter plate. So I'll do a little bit of film when I've finished. I'll remake the cartridge in here, I'll turn all this round, paint it, and it'll end up looking very, very similar to this. I'll even make these, I think. because I like that. That's one of the nicer features. That'd be a fun thing to make, rather than just a bolt through. Really handy little gadget. If you see these come up for sale, grab them, because they very rarely come up, and expect to pay now maybe up to £200. I paid more than that for this one, but was very pleased with it. So there we go, a little bit of work to do to get this to look how it should, and you can see these are the original castings, just with no paint on or anything. Could be machined a lot better, so I'll have a go at just machining this surface here so that it's much finer finish than that, hopefully. This is the refurbished Potts milling spindle that I purchased, mounted on my rivet lathe, and it is very similar to the previous one, and I'll show you a picture to compare it with. There was quite a bit of machining and polishing and painting going on here. It was not straightforward to do. I fitted a new threaded rod, acme threaded rod in here, and I changed this from a simple socket head screw to a Tommy bar arrangement, the same as the original. I had to reduce the height slightly to be able to get this to run onto centre height, and now if I run this right down to the bottom, I get slightly below centre height, which is perfect, and I can get centre height in both directions, both crossways and in from the end. The motor that I'm using up here is a 24 volt 150 watt DC motor, which is used on scooters. It's got plenty of torque, and I think should prove to be quite adequate for the job. And I've got it slightly speeded up here. From memory, this is 3,500 RPM or 3,000, I can't remember now exactly, but it's that sort of order, and I will check it before I use it so I know what I'm actually turning at. The spindle inside here it turned out a 1-inch cartridge in it that had solid bearings in, and I've replaced it with bearings which I had not come across before. I'll just show you a picture of them. They're, make sure that's in focus. They're needle roller bearings on the outside there, and there's a thrust race all built into the same bearing, and these are capable of a dynamic load of 4,680 newtons, static load 4,150 newtons, axial load 5,070 newtons, radial fatigue limit 475 newtons, so they're absolutely adequate for what I want, and the speed with grease is 6,300 RPM, slightly faster if running in oil. They are very small, and this shows the arrangement. There's needle rollers here, and what the needle rollers do, they run straight onto the ER16 collet chuck, which runs through to the back. So that runs through there, and they bear directly onto it. It needed a little bit of work with emery paper just to get it down slightly in diameter. It was a little bit too large for the bearings to rotate freely. They were just it was just under 10 millimeters, the shaft, And the other thing is the shaft is hardened, not terribly hard, but it is hardened, so should be quite adequate for using for a spindle. And then I made up electronics. Sorry, those bearings firstly come from Simply Bearings. And this is a box that contains the speed controller, the regulator, and a connector wire. So as I'm running at 24 volts on the lathe, which is a more comfortable arrangement than running with high voltage, and this seems to work fine. This is adequate for the power that's required for this motor. So I'll just move back to the pot spindle on the other lathe, and you can see apart from the motor, it is very, very similar. So I'm quite happy with that. Worth spending the extra effort, adding little touches like there's a spindle thumb gauge that should be inserted there. It actually isn't graduated on either of them, but it looks a lot better than just being left blank. Unfortunately, the belt that I got for this was a little bit longer than the one on the old lathe, old spindle, which was a foot long, and this is 335 millimeters. It's just that little bit longer. So the motor's just mounted slightly further away, but it's quite adequate as it is. And it all works in that sort of manner, no problem. And similarly, it can be moved up and down the Z-axis like that. Indexing on my rivet is via a plate on here and a spring-loaded plunger sitting on top of the gearbox housing on the top here. And this is, believe it or not, the collet closer that sits mounted in there when you're fitting this. The collet closer is just enormous compared to most of them. You certainly wouldn't lose it. So that's the arrangement for doing the indexing. So a very nice addition to the rivet lathe. I'll just go through one or two of the bits of machining that I did. This rim was faceted and I've just turned it round and as near as I could to the original shape. It was missing a handle, so I made a handle up. Then on here I've turned this round so that it was facing the same direction. This was on the bottom side of the casting, rather than the other way around. It was just not how it should have been. I put a new Acme thread in here, in a bronze thread in. There's a bronze bush in here. It's not exactly the same as the original. The original has this has a split in the casting which is tightened up with the clamp. and on the original there's a rather better arrangement which doesn't have the split in here, and it clamps it with a bush on each side. On this part of it, that gave me the most grief. These two were not the same diameter. Holding this part to machine this and the internal surfaces were very difficult. This one was not that easy, but I had to machine both ends and the inside face, and I made up a new spindle which goes from the thread inside here out to the outside, and it's quite a bit thicker than was in originally, so I had to bore out this casting. Machining these castings isn't easy, and doing it from scratch certainly is beyond most amateurs, I would have thought. And I mentioned this, which is a rotating, just held with a friction fit on the upper surface, and it's loose on the bottom. I have actually got on here a mark, but you can hardly see it across the top to show when it's horizontal. I made the cartridge stick out here a little bit, probably unnecessarily, but I felt something I wanted to do. And the aluminium plate here, which I machined up on my mill, is just a simple 1-bolt fixing, which I've got on the other pot spindle, and that works fine. DC 24 volt motor, is that better or worse than the 3-phase? And I think the answer is you can probably hardly detect a difference between the two. This works perfectly well, and I'm quite sure I'll get good use out of it. Anyway, I hope this gives some useful information about the Potts milling spindles. For those that haven't seen them before, and if you get a chance to buy one, don't hesitate, because they're really useful. You may need to make an adapter plate, and there's no reason why you couldn't make a fresh adapter plate for the bottom and fit it onto a cross slide using T-nuts going downwards